as I said, systems requirement. So once you have the systems requirement, so hardware design requirements is one part of the system requirements. So here is where we deviate. Okay, in the previous slide we said after once the requirements were drafted, okay, so we'll break it down into specific requirements like software, hardware, mechanical. So now we are getting, now here is where from here onwards we'll be getting into hardware. Okay, so as usual, systems requirement. From system requirement, so what kind of hardware, what is the hardware requirements to achieve the requirement, the system requirement? So then it would be like a board level requirement. So my board needs to be my board size has to be of 3 cross 5 centimeters. Okay, and it should be able to accommodate all the functions that were expected. So how many kind of boards I do need to have? Is it, let's say, if I take a mobile phone, okay, should I need to have multiple boards, because you will be having a battery at the bottom or at the extreme of your mobile phone, and you will be having your cameras, and you will be having your control buttons, you will be having power on, power off button. Okay, so like this. So all these things you cannot have once on all these interfaces you cannot have on one single board. Maybe for a battery you need to have a battery section, okay, battery management unit, or a battery battery gauze, okay, where when you plug in your USB or whatever, USB 2.3 or USB 2.0 or USB 3.0 connector, okay, so it should harness the power, okay, and it should charge your battery. So you may be having different. So here is where you will come up with how you are going to take your design. Okay, are you going to have a splits in your board? Okay, so if at all, if there is a split, okay, which board will do which function? Okay, so it will further gets proceeded to electrical architecture. Here is where you will tell, okay, this particular block, okay, the board or block, okay, you can say even on a board you might be having a different blocks, processor block and memory block, okay, sensor block. So let's say you have your mobile phone, you have your ambient sensor. Based on your ambient sensor, your mobile screen display will get controlled, okay. So what, how you are going to have the how you are going to interact, okay. So this will define a very high level blocks, okay. And then further coming to the design, okay, so then here is where you get into the low level design, okay, like what kind of sensor is it going to be? If at all, if it is an ambient sensor, what kind of sensor is it? Just a thermistor or a LDR, okay, light dependent resistor, or you are going for any new technology, okay. Let's say if you are going for a processor, what kind of processor you are going to use? Are you going to use a Texas processor from microprocessor from Texas Instruments, or NXP, or from Qualcomm, or from Intel, okay. Let's say, so here, as I said, the component engineer also will be assisting the hardware engineer. So sometimes hardware engineer will also do the component selection, but not at the very low level. Let's say component engineer will be helping to select some kind of resistors, capacitors, which are very generic. So hardware engineer will set the requirements. Hey, you help me in selecting some resistors of 100 ohms, 10k, 100k ohms, okay, some 0.1 microfarad capacitor. So he set the requirement, and component engineer will select it, okay. And if at all, hardware engineer, mostly he will be involved in selecting the processor, memory like DDR3 or DDR4 or DDR5, okay, and NAND flash or NOR flash. And especially in terms of hard processor or memory selection, hardware engineer will include firmware engineer also in the selection, okay. Here is where once you select your components, so you come up with your design, how you're going to have your design, okay. So let's say if at all, if you need to have a 2 GB RAM, okay, so how you are going to have? Are you going to have one single DDR chip, or you're going to have a multiple DDR chips, okay. All these things will be covered in design and development phase, like schematic, drawing your schematics, creating the schematic symbols, PCB footprints, drawing your schematics, schematics in the sense the circuits, okay, and then generating the net and doing your design rule check and generating the net list, okay, and yeah, and give and preparing the PCB constraint document and giving it to PCB engineer, and PCB engineer will design the PCB, okay. So all these things will be covered as in the tile which is marked in red, design and development. And coming to the proto manufacturing, so proto or prototype, okay, which is like, so it's not a if at all, if any freshers who are not aware what proto means, okay, prototype is like, which is the one which you build or manufacture the product for your testing, okay. Okay, it will not be sold for the customer, okay. You manufacture this for your for your testing and validation, and the definitely this prototypes will be manufactured in very less number, like some 10s or 20 pieces, okay, or some even some maybe 5 or 10 also, like that, based on the requirement, okay. So prototypes, it is just not just required for hardware engineer, even for firmware engineer also prototypes might be required, and for mechanical engineer also it might be required, for test engineer, and for product certification engineer also it might be required, okay. So here is where how the proto manufacturing goes. So generally, if at all, if it is a service based organization, so there will be like let's an HCL or Wipro or L&T, okay. So they will be based on the customer, based on the understanding with the customer. Proto manufacturer might once they design and share the service based companies share the design with the client will take care of proto manufacturing, or if the agreement is made that okay, HCL only should design and get the protos manufactured, they also do that, okay. So but it depends, okay. It should not be understood that okay, manufacturing also will happen in the in-house. So to manufacturing a product, you have so many things, okay, like PCB components, okay. Components will be manufactured. You will have some components from Texas Instruments, from onsemi, ST Microelectronics, some from Qualcomm. Sorry, Qualcomm is a fabless semiconductor company, from Intel and from AMD, like that. So so all this will be taken care by a manufacturing engineer or an industry engineer, okay. And coming to the verification and validation, so here is where you test your proto, okay, and you test it and you see whether you're as I said, whether you are meeting your requirements or not, okay. So let's say you said you have designed a power supply which will output 3.3 volts and it can source 1 amp, okay. You do test it. So all these things, so we'll get in detail what verification and validation, what are the activities that are involved in verification validation, okay. And I think there are some SMEs in verification and validation also in our group, so they can, if any points I haven't covered, they can cover when we get across that particular slide, okay. Coming to, once you are good to go with your testings, and if you have see that okay, is tested and it is good to go, okay, so you'll go for manufacturing or mass production. So the manufacturing or mass production, just I want to add a point here. So it's testing is just not just testing your normal product, whether you're meeting your requirements. So there will be some product certification testings also. So you need to pass those testings, okay, and then only we can sell it to the customer, okay. So that is what I want to emphasize over here. And let me jump to service and support, as I explained already in the previous slide. So service and support, like repairs or giving some technical support, how to use your product, how to install your product, and troubleshooting, if at all, if customer don't know or is not aware of it, okay, how to install it. If at all, sometimes customer will abuse your product, abuse in the, I'm not taking in a wrong way, so abuse in the sense they don't know how to use the device and they will use it in an inappropriate manner, okay. So your mobile phone is not a waterproof or water resistant, okay. If at all if your customer have kept that in water, okay, definitely it will not function. So sometimes when they call up to your customer care, okay, they say these are the limitations of your product and your intended to use only in this environment, okay, so in particular environment. So like that, tech support team does that, okay. Service engineer will be doing a repair or kind of upgradation or anything, okay. Coming to the next slide. Yeah, here is where we can break up the each and the requirements, architecture, implementation, and testing, okay, into sub activities. So as I said, customer inputs. Based on the customer inputs and the system level inputs, we'll come up with the board level requirements. And so when you have the requirement, so it doesn't mean that when you have a requirement, you will straightforward, you will try to implement it. You need to see whether you can achieve this requirement, okay. How to achieve this requirement? You need to have one single board or multiple boards, or what kind of sensors you need, what kind of actuators you need, kind of processor you need, okay. So what is the expectation? So all this happens in the requirement analysis, okay. So very high level, okay. Once you do the requirement analysis, it will ease you to come up with the board level architecture. So board level architecture or system level architecture, okay. So because if I just refer to a PCB board, okay, it may not cover the sensors which stick to your mechanical housing, okay. System level architecture, okay. So once you have come up with the architecture, as usual, you will do the component selection and do some kind of design calculations. And here is where it happens, that is where it happens in the implementation under design and development. So once you decide, okay, let me go with this particular processor, or let me go with the LDO or power supply, like a switching power supply. So then when you are sure with your design, okay, then you will draw your schematics or circuits, okay. If at all you are hearing the schematic word for the very first time, so schematics is in a simple context, it's just like a circuit which you draw on your paper. So since you cannot draw, you cannot import your paper or hard copy into the system, so it will be tough. So for the machine to understand it, so you need to use some kind of a software, okay, EDA tools, electronic design automation tools, okay, to draw your circuits. So that is what we call it as schematic design, okay. So schematic design will include some kind of a components, okay, like when you have a resistor or a capacitor, okay, you need to create some schematic symbols. And for ICs, some processors, okay, all these things happen in the schematic design. So once your circuit is ready, okay, design your circuit, okay, so you need to check, okay, definitely it's a good design practice and it's must, okay. You need to check whether your connections are proper or not, and whether you have done any wrong connections. All these things will be checked during design rule check, DRC. And sometimes not most of the times, we do a schematic apart from the person, the designer. So there will be some subject matter experts or seniors will be reviewing your schematics before you share it with PCB engineer to draw the PCB or design the PCB, okay. So generally, typically, so you give your netlist and your PCB constraint file to the PCB engineer. So if you see the few linkages to this schematic design, timing analysis, pre-SI, PCB constraints, PCB schematics, symbol creation, library, component footprint creation, okay. So all these things will be part of it, okay. So you have, it's not just hardware engineer will take care of all these activities, okay. There will be different teams, as I have mentioned well ahead in our session, okay. So PCB constraints will be set by a hardware engineer. What is PCB constraints? So I will be emphasizing a little bit on this particular thing in upcoming slides, but let me give a heads up on this. PCB constraints. So if at all, how you, like, so you